Once again, hello everyone, and today I will make a trip on the obfuscated assembler. My name is Vladimir. I am doing the reverse engineering starting from 2016. I was a forensic and also was doing the commercial software, and now I'm working for 4 years in a solar company where I'm dealing with the malware, and I'm head of the group of analysis of the imported code. What I'm going to speak about. On the one hand, it's been described in 2 articles, in 2 parts in our forest blog. Besides, some of the tools I covered in 2023, how they could be applied practically. Therefore, today there will be now technical details, and also I will not share any one-size-fits-all methodology how to reverse the malware with obfuscation, but I'd like to show you my way, my journey, why I took certain decisions, why I'll be using this or that approach, and I will show some memes and quote some people. And as I said, we're not like that. So what I wanted to say about that, don't give a fish, but give a fishing rod. And for instance, have you ever heard about Malprotect? When I started dealing with the questions of obfuscation, I would find a lot of articles, including the popular ones that, for instance, we deobfuscated mprotect, and now it's okay, but mprotect evolves, and certainly all those tools and instruments and methodologies are underlined by the same approach, just they are being used differently. And these are the approaches that I'm going to speak about, the approaches that are used there. I think that this is a more common thing, which is applicable in different cases, including the ones that are going to run in your real life. And before we start, I would like to ask you, raise your hands, those who heard about Packer, who know what obfuscation and deobfuscation is about. Okay, thank you so much. It all started 2 years ago. We ran into one sample that one of my colleagues has to analyze. The very idea was in order to identify the functionality, the series, or the family, and to answer the question what it is about. And he was not dealing with how the packer is working, he was just reaching the goal. And it took him about 5 years in order to unpack that. And inside there was just a stealer, and I'm putting it like that because the functionality was very scarce. It was stealing some data, sporadic data, from Chrome, and would put in some folder. And similarly 5 days in order to say that the functionality is quite weak, is no good. And then I was rushing to somehow deal with something obfuscated, but that case gave me this opportunity, because now I got an opportunity to somehow in future accelerate the packaging of that packer and to get some life hacks how to do that better. And ideally, it was a quite difficult idea in order to make my own packer for fun. And I made my first mistake there. I thought that being armed with ID Pro and probably ID Python, I would immediately defeat that packer, but no, and there were many stages ahead of me before I could unpack the packer to say how it works and to unpack the payload. When I got the sample for analysis, certainly I opened that in IDEA. And as far as actually I said that we'll show to you my journey, let us start with that. Entry point showed that there's a GMP instruction or guidance. And actually it was stored somewhere in the memory. If you look deeper, you will see some pattern, which is catching the eye that there is some useful guide, and there is a jump, and there is another guide, another jump. And here I run into the very first bus. This is a GMP instruction or a guideline. And if we look broad at that situation, you will see that then that pattern, useful guidelines and a jump with some sporadic 3 bytes, they are divided into some base blocks. So the guidelines, which were in the original software, they are divided just this way. And then it seemed to me that they are spread in some accidental spaces in the memory. Apart from such obfuscation, there was a multi-step coding, and every stage would be coding the previous stage without adding any new logics. So I just saw that another stage has been deciphered or decoded, and that's it. And one of the latest TJ would decode big chunks of function, which would unpack the payload, some methods in terms of detecting the debugging and sandbox, etc. And a very important nuance there is that the key will be generated proceeding from the code that is decoding next stages. So it means that I cannot use the software entry points. Don't know how they are implemented. Well, actually, for the rest, let me explain. Once actually you use a debugging, then actually those stop points or the breakpoints would make a break when the software actually is running the guideline. It would be intercepted by the debugger, but the debugger would not show that the memory has been changed. If we put a breakpoint, it means that we are changing the key, and it means that we will not see our payload and further guidelines. And besides, you cannot use the hardware breakpoints, but that was a rare case and there was just some checks. Therefore, without thinking twice, I decided that why not doing emulation instead of using the debugger. I opted for Unicorn, and emulation works like that. We are uploading some bytes, some data, some guides, and in essence we get a full control over the situation at hand. And so it means that we can change any time the memory, the values in the register. We can jump from one point to another point, and you can log that. And that was quite cool. Besides that, Unicorn was familiar to me. And as far as this is an emulation, I don't have to think about further coded stages. I just run the emulation, and next stages would be decoded, and I make a track. I enjoy my life and do not think about unpacking or anything like that. But I didn't use the Unicorn itself, but I used the wrapping flyam, which helps to distribute in the memory those segments of the executed file that are available. So I'm just upload that file to that program and do the emulation. I make the track, and that's it. And besides that, very often I'm using flyam in order to decipher some lines in obfuscator or Harbor or anywhere else, because there are life hacks, for instance, copying of the memory, comparison, etc. And besides that, there is an opportunity to turn to the name of the function directly.
Итак, инструмент я выбрал, и как же я его применял?
And so how I use that tool? So I upload, as I said before, the executive file.
Дальше собираю трассу, ее фильтрую. Здесь я еще накладываю.
And I do filtering, and I introduce some execution, and Unicorn helps to limit not by execution, but for instance by certain addresses, so indicating the addresses within which I'm going to execute something. Or at least the emulator would do that, and then it would stop the emulation. I'm sticking to the guideline because I do not know the right addresses, and I make the trace, and I make the executive file, and out of the filter trace to the PE route is very difficult, at least for me, and I'm not going to tell you more about that, fortunately or unfortunately. Then I upload that. and see what happens. Suddenly, I had to do some debugging, and everything is quite standardized. And sometimes I would put the trace into the text file in order to find some errors to understand that we need better instructions or guidance, guidelines. And sometime later, eventually I would get not what I wanted to see, and I thought that idle would recognize that as a function, but in essence, GMP guide was hacked thanks to equord, and then doing some research. I actually identified that there are some unclear predicates. Do you know what it is about?
Неявные предикаты — это такой вид обфускации, который добавляет ложный вид влияния.
This is actually a kind of an obfuscation. When we have an execution flow, and here we add some conditional transition, which is terminated, either it is false or it is non-false, and we generate another branch. Sometimes that transition might be positive or false, and then the second false branch would be generated proceeding from the main branch, which was just it would be obfuscated or complemented to understand that these are the same patterns. How it was implemented here? It was done on a binary level, therefore, no one had to think about setting up that false branch, and would jump to some nearby place in the memory. So disassembler would collapse because of that. Here I show that, for instance. We have two labels, some jumps, one to the beginning of the guide, E09, that's another jump right to the middle of the guide, all of a sudden. Besides that, sometimes those are non-evident or implicit predicates are introduced so that at first glance you cannot understand whether it is terminated or not terminated. So here they just take the previous guide, and regardless of the operator of that instruction, you can understand whether there would be a jump or not. And the main tool in order to combat implicit predicates, that's the symbol execution. I will elaborate on that a bit later. So it looks like emulation, but instead of the new emulator, when everything has been executed, you get a mathematical formula and can ask some questions. For instance, at what entry parameters of that function I would reach this or that branch. Or I can learn when entry parameters have to be obtained in order to get some specific value. It works very well once we have a very simple hash function, for instance, which is being used in some write-nick in order to obfuscate some functions that are being sent by the server. And the primitive execution is needed in order to get some hash tags. But in our case, in my case, I ask a question whether we can reach this branch at all. It would be enough to perform two functions, and I opted for triton because actually it's written on C and this works much faster. And I symbolize all the registers, so it means that by default all the symbol engines are working with symbols, not with the variables, so to say. And to symbolize a register or some memory cell, it means that you tell a symbol engine that you have to perceive that as a variable, and you can use some mathematical formula instead of that. After that, I execute that in triton, and triton would advise me whether there will be always a jump, and depending on the situation, for instance, either I would make that conditional transition or I would replace that with the unconditional transition. Okay, we do have that rationale, that logic, and I built this way after I assemble the traces. Why? Because emulation always would go the right way. The emulation by nature is emulating the processor, where the CPU, and CPU always works the right way. I don't have to get into the emulation process, and I can filter the tracing after I assemble the traces. So this is in addition to the tracing, to filtering. And here I get it. That's an executable file that I can embed anywhere I want. And suddenly I got shivers as if I addressed a very difficult problem and got a flag. So why I opted for the emulation? So there's a multi-step coding was ciphering, as I said, encoding. Emulation certainly was a big help, and emulation helped me to do that. The breakpoints that I didn't have to use, again, it doesn't matter because that's an emulation. And another takeaway, for me, it helped me to debug the decoding script, which helped me later on. That algorithm of decoding, I met it several times further on in that packer. Here I added triton, and for instance, the implicit predicates were defeated. But here I run into another problem, just a big deal of different functions I had to deal with. And why this is a problem? Because when we're approaching big deal of different functions which are being executed by the code, either have to emulate the code from the very beginning, because the memory, the emulator, and the register would matter. Otherwise, I would get non-complete covering all the functions. So there would be a check whether the indicator is 0, and I would be dropped from the function. So instead of function, I would just get out of the function, would be dropped from the function. So I tried to keep the emulator's status from point to point. I wanted to guess it right, but it was of no help. And that problem has become very critical for me. But who I am to actually argue against Statham, and I moved forward. So I started implementing my own algorithm using Pepstone. So I ran into the following problems. First of all, I had to decipher the code on my own. It was not a problem, because at the moment I had a deciphering script or decoding script, and I got an executable file with all the functions, but they were obfuscated. It was very unpleasant to look at them. And besides that, there were some implicit predicates, and I had an algorithm how to bypass them. And removing GMP guides, this is not a logical way, because they may be used for the good purposes as well. It means that we had to find some logics as to what GMP functions could be removed and what should not be removed. And here, it occurred to me, I tried to draw all the graphs where GMP instructions where guides could be used. And certainly, I didn't consider the GMP transitions that are being used as arguments, some variables or some area of the memory. So I look at the jumps to some labels. There's a rationale. The GMP transitions which are good, they always would refer to the guide with 2 or more Pietkovs. And following from that, I could do something. And certainly, it cannot be proven mathematically, and I drew several graphs that would deny that. And I thought that probably it would be okay, but unfortunately now, again, I had to deal more with that, and eventually I deobfuscate the code itself, and this is an assembler view of the function. So one of the nodes, for instance, the left-hand side, it actually gets the references from other nodes as well. A decompiled way, a view looks like that, for instance. That's the end of one conditional transition, and the function is returned, and subsequently we see that there is another functionality there. So it means that I have a full coverage of the code, similarly. Eventually, with the time, I confirmed by empirical data that the full coverage of the code was obtained, but I accelerated the work because emulation works too long, especially when we run into cycles. When I reached the moment when I had to decode big pieces of code, then certainly the emulator would work too long, very slow. And I upgraded my skills of building algorithms. I remembered my past when I did some programming. So I replaced unicorn with a capstone that helped me to cope with all those functions. A few words about debugging, and certainly it was the same except for one thing. I'm working with a graph flow of running, so it means that the graph could be visualized. I took Gephi model and would upload the whole trace, all the graph flows that I would be building, the initial ones, the ones which are purged from GMP functions. And here you can see, once you see arrows, that there is a bigger cycle, less cycle. This is the main routine to decode other stages. And as an example why, it helped me not only to visualize the graph, but also to find some logical mistakes in the process of purging these graphs from unnecessary instructions. Every summit there is one individual guide, and the transition from one summit to another summit, one peak to another peak, this is actually how we proceed from one guide to another guide. If it is GMP transition, it means it is preceded by some GMP guide, conditional, non-conditional transition, etc. There should not be a case when we are proceeding to one guide using two flow transitions, because we cannot keep in mind two guides. Either this is a type of an obfuscation that allows for that, enables that. If we look at that more attentively, then there is really one GMP transition which is indicated as a flow transition, and it impacted how we upload the flow into the executable file. Very often I would run into the false conclusions and how the function works. But before proceeding with the takeaways, let me make some comments on the sidelines. For instance, these would be useful for the developers. Let me start with saying that all those patterns are united into the baseline units that are stored somewhere in the memory, and they are localized. What it means? There was never a case when I would find some unit or some block from one function in the middle of other functions. Why it played into my hands? Because in ID, I could open that file, and there would be some implicit predicates, and if you purge that, then I can ask ID to define the function, and there would be some GMP transitions that get some bytes inside, and still it would take the function and decompile that. And once we decompile that, I do not see any conditional transition. So for me, it would be much more difficult if those blocks or units are somehow dispersed in the memory. Besides that, that GMP transition pattern repeated for the implicit predicates as well. What I mean? Instead of the payload, you will never find that implicit predicate would be on the place of the GMP transition. So using that pattern, you can identify whether that conditional transition is non-conditional. Conditional transition is a predicate or not. So, and certainly, the dependence of the conditional transitions on the previous guides, and that simplified my life. Usually in such situations, people try either to use some global variables or some sophisticated mathematical formulas. And here it was enough in order to execute the previous guide before the conditional transition. That's it. Yes, I had some plans, some unwishful thinking, and I thought I would cope with that packer within a couple of weeks, and eventually it took me months, a month and a half. I thought I would get a fully deobfuscated packer, but I failed. And also, I didn't make the full unpacker, so that I say some utility and I put some packed file and get unpacked file. But I managed to get the unpacked file, which is made with imported elements. Why? Because we need more time. And when I was a student, I got such an idea that, for instance, if you are doing some push things, then it is a cool thing to do, but it is not so, because the life is harder for us. You have to find why those results are useful. So those results are not very much useful. Let me explain why. The very idea was to get some life hacks, to understand how in future you could unpack those packers in an easier way, faster. And I actually wrote a whole article about that, and besides, I came up with the following conclusions. Well, making a full obfuscator is not a very grateful thing. Most likely you would get some scripts or some life hacks that would help you eventually at one moment of time to understand the logics. And the time you spent on that script actually is much more than just doing that manually. And again, for debugging, not always you can use the debuggers, but you can use also some interesting tools and instruments. This was my journey. So, completing that journey only this way, I managed to cope with that packer. I cannot say that in the very beginning I did it bad, that I used an emulator. In the very beginning it helped me a lot. And probably if I were deassembling that using capstone, still it would be much slower, because I had to replicate E-code, where would replicate or copy-paste some things from the emulator. Initially, I didn't think about certain things, but it helped me to understand something much better and much faster. Why, actually? I'm telling you that 2 years, from 2 years ago, although it happened 2 years ago, because we ran into a very difficult sample that we analyzed, and we didn't run into that anymore. Fortunately, unfortunately, this is really true, and making unpacker or full deobfuscate doesn't make sense, because we already had the unpacked file. And I had some tips as how to unpack that file, and it seemed to be quite enough. I thought there would be more scripts, and I would disclose that topic fully, but no. So I'm done with my presentation. Thank you so much. In our blog, you can find more technical details. In 4 Rays, our Telegram channel, we're telling more about the cyber attacks that we are facing right now, and my Telegram to get in touch if you want to communicate. Thank you so much for your attention. I'm ready to take your questions. Okay, then. Well, so the organizer has gone. That obfuscate, in essence, was a commercial packer, and the article tells us about that, but we didn't use the commercial use of that packer. As for the labor cost, actually, it took me a lot of efforts, and probably this is not the latest version of that packer. And I just think that initially they went step by step, making it more difficult to analyze that code. This is not mProtect, but compared to mProtect, for instance, it has less limitations in terms of the resources that you are using that are needed for protection.
Да.
Yes, yes.
Можете переформулировать, может быть?
Can you rephrase that? I just failed to understand your question.
Насколько мне известно, то
As far as I know,
искусственный интеллект это больше про
artificial intelligence, it is more about the scales or weights and data, but they're very rational of using those weights for a different. It can be executed as the interpretable language, not executable. So, and this is a totally different thing, and it's very difficult for me to compare those things. Well, I'm not sure whether I answered your question. Yes.
Ну, я в самом начале рассказал, что моему коллеге потребовалось 5 буквально дней, а я...
So, as I said, it took about 5 days. It took my colleague 5 days in order to do that, and it took me months and a half. And he didn't have to analyze fully that obfuscation. But my idea was to reduce that time from 5 days to a little bit more than an hour. And therefore, I wanted to deep dive, to delve deeper into Packer. So I put such an objective forward to me. So certainly, if you have to consider the functionality, then you don't have to do all those stages. But there is another thing. There are different types of protection from analysis, including the dynamic analysis. And for instance, if we see some noise, then probably there is just something more than ping C2. And therefore, probably it would make sense to study the obfuscation. So in the framework of my report, I spoke about obfuscation. And there were many ways of detecting the sandboxes, some virtual machines, and some hardware breakpoints, etc., etc.
В блоге я вроде должен был описывать этот момент.
Спасибо. Здравствуйте. Спасибо за доклад. Вопрос у меня такой. Был опущен момент с восстановлением PE-файла. Разобран ли он в блоге? Мне самому интересно. Вопрос, как их восстанавливать в памяти, когда они вот уже разошлись, когда оно распаршено.
Well, once we parse that and it's been used by the members, how we reassemble that afterwards? Okay, let me remember.
Я там писал точно о том, как сдампить PE-шник. Ну, там не PE, конечно, там...
So sadly, this is not about PE.
Но тем не менее...
There were no headlines, but nevertheless,
Единственное, там проблема есть с импортом.
there is only problem about the import because it builds its own table of imports, and you have actually to spend time on that, but nevertheless.
Более подробного разбора там этого вопроса не было.
Да.
But
Спасибо.
there was no more detailed analysis about that. So I was asked to ask you to write more about that.
Да, вот это вот все расследование, исследование, вот эти все находки.
So there's investigations in life hacks, certainly.
А вот именно
are quite useful, but in terms of your work,
куда это потом можно выгрузить? Ну,
where actually you can use that apart from
помимо хранилища знаний, где
some
они
repository of
используют
knowledge,
вот
are you using those tips anywhere else, so that
которая
information that
со статистического разбора.
you got from that investigation, from that analysis?
Мы стараемся все интересные случаи выкладывать.
We try to actually analyze all those interesting cases in our blog. We're publishing different materials about the activity that we see, what cyber attacks are there, and speaking about the hands-on application, then certainly we share those practical cases as well. So, I mean that already now there are some intellectual systems.
Как-то это можно интегрировать?
Can we integrate that somehow?
Могу представить себе как.
I cannot imagine how we can do that, but just a question. Probably we can do that eventually. There are different platforms, and in the context, for instance, we start doing that.
Ну, то есть типа ИОКи такие.
So the lights are okay.
Блоги, статьи.
There are some blogs, there are some articles. Yep.
Я так понял, что больше вопросов нет.
I understand there are no more questions then. Thank you so much. Thank you. Thank you for your time. Thank you.